In this video, I'm going to tell you the oxidation number method of balancing a redox reaction. This is very important method, a very easy method. I will be taking help of one example to explain that. So the steps you need to follow, there are total 5 steps to be followed for oxidation number method. The first one is write the skeleton reaction with correct formula. So I'm taking just example of this reaction where dichromate ion reacts with sulfite ion gives you chromium ion and sulfate ion. And I am saying that it is acidic medium. It can be basic medium, it can be acidic medium. In few reactions, I will be talking about acidic medium, in few basic medium, and it will affect the way how we balance the reaction later on. After that, there is an extra step which is not written in NCERT, but you have to take care of it. Otherwise, you will not be able to balance the reaction in many cases. That is, balance the evident ones. So here, if you see, you have two chromiums and chromium is available only here on the right hand side. It means on both sides you need to have two chromiums. So you will write 2 here just to ensure that, because this chromium comes only from this particular compound. So both must have same number of chromium atoms or ions. Then the second step, assign oxidation number to all elements in the reaction. When we say all, it does not actually mean all elements. It means only those elements which actually change the oxidation states. In this particular example, if I see oxygen is present in normal oxide form only, whether I consider dichromate, sulfite or sulfate, I don't have peroxides, I don't have free form oxygen, I don't have ozone, I don't have oxofluorides, and I don't have superoxides. It means oxygen can have only -2 oxidation state. So it will not change its oxidation state. I will not bother about it. I will bother about only those elements which will change the oxidation state, means getting oxidized or reduced. So if I calculate the oxidation state of chromium here, so I'll say chromium has oxidation state X. So 2 times X, why 2 times X? Because I have 2 CRs here, plus 7 times oxygen -2 normal oxidation state. So 7 times -2. The sum of oxidation state should be equal to the total charge on that ion. Total charge here is -2. So write -2 here. 2X will be equal to 14 minus 2, that is 12. X will be +6. So oxidation state of chromium here will be +6. Now here, oxygen will have oxidation state -2. I will not bother about it. I will bother about sulfur. It can change its oxidation state. So to calculate oxidation state of sulfur here, I'll say assume that oxidation state of sulfur is X, then 3 times oxygen, that is -2, equals to total charge here -2. So X will be equal to here 6 minus 2, that is +4. So sulfur will have oxidation state +4. Then on right hand side, chromium is monoatomic ion. Monoatomic ions will have same oxidation state as the charge there. So the charge is +3, oxidation state will be 3. Chromium on the right hand side will have +3 oxidation state. Now coming to this sulfur in sulfate ion, assuming that sulfur has oxidation state X, then it will be +4 times oxygen. Oxygen is -2, and sum of all oxidation states will be equal to the charge, that is -2. So X here will be 8 minus 2, that is +6. So I've got all the oxidation states which are changing, okay, which are not same on left hand side and right hand side, which are changing. So these are the oxidation states. This is the second step. Now the third step. Third step is we need to calculate the increase or decrease in oxidation number. So as you can see here, the oxidation number decreased here. Oxidation number of chromium decreased. Remember, I am writing 2 here because it was very much evident. I have done it as extra step. And sulfur oxidation state increases. So here oxidation number decreases. How much it decreases? 3 minus 6, that is, it will be -3, change of -3, final minus initial. Final is 3, initial 6. In sulfur to sulfur here, in sulfite and in sulfate, the oxidation state is increasing. How much it is increasing? 6 minus 4, final is 6, initial 4. 6 minus 4, that is +2. So we will calculate the increase and decrease in oxidation state per atom. So whatever we have calculated here is per atom change in oxidation state. Remember, when we calculate the change in oxidation state, it is first for atom, per atom. Now we need to calculate the change in oxidation state for entire molecule or ion. It is simply that you will consider the number of atoms present in that molecule or ion. So if you see here, how many chromiums are there? You calculated this +6 oxidation state. It was for 1 atom. Remember, it was for 1 atom. So we will calculate for 2 atoms, what will be the change? So the change will be -3 into 2. So per atom, it was -3. But per molecule, it will be -3 into 2. That is -6 per molecule. Similarly, I will check for increase in oxidation state also. Here, how many sulfurs are there in sulfite ion? There is only 1 sulfur. It means per atom and per molecule will be same. Whether I say +2 per atom and +2 per molecule, or per ion, it will be same. And the reason is there is only one sulfur in one sulfite or sulfate ion. I'm just writing it here ion because dichromate is ion, so per ion. If it is molecule, I will write per molecule. So the decrease in oxidation state per molecule I calculated as -6. Increase in oxidation state per molecule or ion I calculated as +2. That is the third step. After that, within third step, I need to equate these increase and decrease. So what I need to equate? 6 and 2. So here it is 6, here it is 2. I have to make them equal. To make them equal, what I need to do? If I multiply 2 by 3, I will get 6. So it means decrease and increase both will be same if I multiply the increase in oxidation state by 3. It means if I multiply this part SO3 2 minus 2 SO4 2 minus by 3. So if I multiply this part by 3, I will have 3 SO3 2 minus here and 3 SO4 2 minus here. So understand it very clearly. What I am doing, I am multiplying that part in which the change in oxidation state is 2, so that the change in oxidation state becomes 6, because the decrease is also in case of dichromate ion is 6, so increase must be 6. So third step is you need to calculate increase and decrease per atom, then per molecule or ion, and then make them equal. Now try to understand why I am saying that multiplying by 3, the change in oxidation state will be 6. So even if you don't write it like this, if I have multiplied it by 3, then per atom sulfur oxidation state in sulfite was 4. But now I have 3 sulfurs here. So oxidation state here will be 3 into 4, that is +12. So total contribution of sulfur in this much 3 sulfite ions will be +12. Similarly, 1 sulfur in sulfate ion had +6 oxidation state. But now I am considering 3 sulfate ions. For 3 sulfate ions, the oxidation state will be contribution of total oxidation state will be 3 into 6, that is 18. Now you can check what is the difference. The difference now is final minus initial, that is +6. So after equating the decrease and increase in oxidation state per molecule, we get this reaction. So third step is to equate the increase and decrease per molecule or ion. Third step done. Now the fourth step. Fourth step is balance the charge. How to balance the charge? Charge will be balanced either by adding H plus or OH minus depending on whether the medium is acidic or basic. So if the medium is acidic, I will add H plus to balance the charge. And if the reaction is in basic medium, then I will add OH minus on appropriate side to balance the charge. Now consider the same example. We have completed the third step, and after completing third step, I have 3 and 3 here. Now see how much charge, total charge is there on left hand side. On dichromate ion, I have -2 charge. So on left hand side, I am considering on left hand side -2. And then I have on sulfite ion, 1 sulfite ion, I have -2, but I have 3 sulfite ions. Means it will be total 3 into -2, that is -6. So total charge on left hand side is -8. Right hand side, chromium ion has 3 positive charge, but I have 2 chromium ions. It means +6 total contribution of chromium ion. And sulfate ion, 1 sulfate ion has -2 charge, but I have total 3 sulfate ions. It means I will have -6 contribution from 3 sulfate ions. Total, if I calculate 6 minus 6, 0. Now this is imbalance in charge. On left hand side, I have -8 charge. On right hand side, I have 0 charge. And this particular question says it is acidic medium. So if I go back to the question, it is acidic medium. And if it is acidic medium, I need to add H plus ions to balance the charges. If I add, suppose if I add 8 H plus on right hand side, then what will happen? It will contribute 1 plus, and there are 8 hydrogens, that is +8. So I will have +8. It is imbalanced. It is not balanced. Here I have +8. Here I have -8. So it is imbalanced. I need to make sure that on both sides, charges should be same. If it is negative, it must be negative. If it is positive, it must be positive. So I cannot add the hydrogen ion on right hand side in this case. I will have to add hydrogen on left hand side so that -8 and +8 get cancelled and I get 0 on left hand side as well. So what I will do? I will add 8 hydrogen ions on left hand side. Now you check. -2 contribution from 1 dichromate ion. -6 contribution from 3 sulfite ions, +8 contribution from 8 hydrogen ions on left hand side. So total, if you see, it is 0. On right hand side, I have +6 contribution by 2 chromium ions, and I have -6 contribution from 3 sulfate ions, total 0. On both sides now I have 0 charges. So I balanced the charges by adding hydrogen ion. If it would have been basic medium, I would add OH minus ions on the right hand side. In that case, OH ions on right hand side will make the sum -8, and left hand side, right hand side, both will have -8 charge. But acidic medium, I will add H ions. Now the last point, fifth point. Fifth point says make the number of hydrogen atoms on the two sides equal. So in the last step, if you remember, we added 8 H plus ions. This may result in imbalance of hydrogen ions on both sides. In few cases, you won't require this step. If hydrogens get balanced automatically, in few cases, you don't need this step. But in most of the cases, you will need this step. In most of the cases, hydrogen will not be balanced. You have to balance it. And how do you balance it? You balance it by adding H2O molecules on appropriate side. So if you have excess hydrogen atoms on left-hand side, you will add H2O on right-hand side. If you have excess hydrogen ions or hydrogens on right-hand side, you will add water molecule on the left-hand side. Here, if you see, I have 8 hydrogens on the left-hand side. Total 8. Dichromate ion doesn't have any hydrogen. Sulfite ion doesn't have any hydrogen. I have only 8 hydrogens on left-hand side. On right-hand side, I don't have any hydrogen. None. So it means I have to add 4H2O. I have to add water molecule to balance the hydrogen. 4H2O will have 8 hydrogens. Now I have 8 hydrogens. Oxygen will get balanced automatically. So if I add now water, 4H2O on right hand side, I have same number of hydrogen atoms on left hand side and right hand side. And you will see that oxygen will get balanced automatically. You can check. Oxygens here, 7. Oxygens here, 3 into 3, 9. 7 plus 9, 16 total oxygens. On right hand side, 3 into 4, 12 oxygens. Plus 4 here in 4 H2 molecules. 4 plus 12, 16. On both sides, you have 16 hydrogen atoms. Everything is balanced now. 2 chromiums on left hand side, 2 chromiums on right hand side. Okay, 3 sulfurs on left hand side, 3 sulfurs on right hand side. Oxygens, I have shown 16, 16, hydrogen 8, and 4 into 2, 8. This is the balanced reaction.